Okay guys, in today's video, we're going to talk about the EIGRP Stub Site Function and really understand the concept completely. In the previous video, if you remember, we configured the stub router on the internet side to avoid sending the huge amount of data center traffic through a weak WAN link. It actually worked well, but now we've run into a new problem. After enabling stub feature in the stub router, we noticed that the router doesn't advertise the networks behind it anymore. Even the networks that should be advertised, like the ones behind the site router. The site router is here. They are no longer visible to other routers in the topology, which is the problem. Remember, the goal is not to make this router a transit path between data centers when the main link goes down. But at the same time, we still need certain networks behind the site to be advertised, right? So the question is, how do we stop the router from being a transit device but still allow it to advertise the specific networks we want? This is the moment where EIGRP Stub Site Function comes in. With Stub Site, we can tell EIGRP is exactly which WAN links are not allowed to advertise routes from. In other words, we can filter out the interfaces that shouldn't be used for advertisement, while still allowing the router to advertise the networks that are very important, like the LAN behind the site router here. How it works? We get into stub router in the middle and we inform the EIGRP router which links are stub site WAN interfaces. And after that, EIGRP actually knows that stub router is no longer a transit router for data transmission between data centers after the main link between DC routers goes down. So data centers actually know that they've got to wait for fixing after breaking down the main link between DC routers, because there is no alternative path for data transmission, right? But on the other hand, the networks behind the other routers that are connected to stub router, which the links are not stub site WAN interfaces, they continue to work nicely. So the networks behind, for example, site router, network 10, 20, and 30 are going to be advertised in the topology with no problem. But guys, the EIGRP Stub Site Function is only available under EIGRP named mode, so remember that. Okay, now we are in stub router CLI here. What we're supposed to do in this scenario, guys, as I told you before, we actually wanted to disable this stub router from becoming transmit router for data transmission between data centers. When the internal main link between DC1 and DC2 routers goes down, we actually don't want this stub router for becoming transmit router, an alternative path for data transmission between these data centers. If you ask me why, I completely explained why is that in the previous video. That's because of WAN consideration. That's because of the huge amount of data centers traffic, right? So we've got two options for resolving this. The first option is to enable stub in the router, as we did in the last video, but we ran into some problems in the topology. We actually lost all of the networks behind the routers were connected to the router, right? So for example, there is a router which is connected to our stub router, which is named side router, and there are 3 networks behind that, and all of the networks are lost and they're not going to be advertised. So we don't want this, guys. We need another solution. So the second option is to enable Stub Site Function. How? We actually inform the EIGRP which links are going to be Stub Site WAN interfaces, right? And then EIGRP knows that stub router is no longer transit router between the sites that their links are specified as WAN interfaces. So in this topology, the sites are data center 1 and data center 2. So after specifying the links that are connected to our data centers as WAN, stub site WAN interfaces, our stub router is no longer alternative path and data transit in our topology. And on the other hand, the networks behind other routers that are supposed to be advertised in the topology, they're going to work properly. To do that, we get into EIGRP router configuration. So we get into EIGRP router with name CCNP, for example, and then with AS number autonomous system 1, and then we have to get into the interfaces that are connected to our data centers. And after getting to the interface which is connected to our data center 1, which is 0/0, with inputting the command stub site and stub site WAN interface, and this interface is now stub site WAN interface. And then we exit, we get out of that interface, and we get into another interface which is 0/1, which is connected to our data center 2, with inputting the command stub site WAN interface. This interface is stub site WAN interface as well. And we exit, and with inputting the command EIGRP Stub Site, we actually have to input an attribute. Don't take it serious, guys. You just have to input an attribute. In this case, I'm going to input, for example, my AS number 1 and column 1, for example. It's not that important. And after inputting our attribute, our project is done. The stubs router is no longer transit router after breaking down the main link between data centers, and all of the networks behind site router are going to be advertised and the connections are okay. This was all about stub router and stub site function. Thank you guys for watching. I hope you enjoyed that. Please like and subscribe my video if you want to watch more videos like this. I see you soon. Thank you. Have a good time. Bye.